Good morning, dear students. Today we are going to discuss the topic blood glucose sensor. We have already seen what is sensor and what is biosensor. Sensor is a device used to convert physical or chemical reaction into an electrical signal. A blood glucose sensor is a biosensor used to measure the concentration of glucose in the sample blood. It is widely used by diabetic patients for regular monitoring of blood sugar levels. A glucose biosensor mainly works on the principle of electrochemical detection using the enzyme glucose oxidase. It mainly uses biological element, transducer and electronic system. Biological element is an enzyme, transducer is an electrochemical electrode, and electronic system is combination of signal processing and display unit. It converts a biochemical reaction into an electrical signal. Let's discuss about main components of a blood glucose sensor. The components are biological recognition element, transducer and membrane layer, and electronic signal processor power source. Biological recognition element is an enzyme. Transducer consists of three working electrode system, that is working electrode, reference electrode and counter electrode. Next is membrane layer. It controls diffusion of glucose and protect enzyme. Electronic signal processor consists of amplifier, analog to digital converter and display unit. Amplifier used to amplify the analog signal and analog to digital converter used to convert the obtained analog signal into a digital form. Display unit display the digital signal. Power source is a small battery. Next is principle of operation. Here electrochemical or amperometric principle is used. The enzyme reacts with the glucose that produces electron. The flow of electron generates a current. The current is directly proportional to the glucose concentration that is present in the sample blood. Let's detailedly discuss about step-by-step process. The first step is blood sample application. A small drop of blood is placed on the test strip. Capillary action draws blood into the reaction chamber. The blood reaches the enzyme layer. The second step is enzymatic reaction. The enzyme glucose oxidase reacts with the glucose. That is chemical reaction. Then it produces gluconic acid and hydrogen peroxide, that is H2O2. The amount of H2O2 is directly proportional to the blood in our glucose. Electrochemical oxidation is the third step. At the working electrode, hydrogen peroxide is oxidized. Electrons are released. These electrons flow through the electrode. The fourth step is current generation. The movement of electron produces an electric current. The magnitude of current is directly proportional to the concentration of glucose in the sample blood. High glucose represent more hydrogen peroxide and more hydrogen peroxide represent more electron. That more electron leads to higher current. The fifth step is signal conversion. The signal conversion is the analog current signal is amplified by using amplifier. Converted into digital form by using analog to digital converter. A microprocessor calculates glucose concentration. The sixth step is display of result. The processed value is displayed on the screen, that is measured by milligram per deciliter. It takes 5 to 10 seconds. These are the advantages. It is fast in response, small blood sample required, portable and high accuracy, easy to use. Limitations are enzyme degradation over the time, temperature sensitivity and calibration required. These are the application. Mainly it is used in diabetes management. It is mainly used for diabetic monitoring. It can be invasive, minimally invasive and non-invasive. Invasive means it requires blood sample. Minimally invasive means it requires small amount of blood sample. Non-invasive does not require any blood sample. ICU monitoring. Doctors can monitor remotely and it is used for clinical laboratories as well as research application. Thank you.